morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are going to talk some quadratic equations as we listen to the great ABBA in the background. Let's get to it, shall we? We'll get back to Waterloo in just a second. Quadratic equations. What makes a quadratic a quadratic? It's a polynomial whose greatest degree is 2. Okay, it's a second degree equation. Meaning the greatest exponent is 2, and it must have that, or it's not a quadratic. Okay, solving quadratic equations. You can read through this if you'd like, but the biggie here is the Null Factor Law, which I would rather call the zero product principle. Okay, zero product principle, otherwise known as ZPP. And anytime I say ZPP, you reply with, yeah, you know me. ZPP, yeah, you know me. And if you don't, you fail for the quarter. That's it. And all the Null Factor Law says is if A times B equals 0, then either A is equal to 0 or B is equal to 0, or actually both. And that is the beauty of the Null Factor Law. Okay, and so if we factor it, all we need is one factor to be equal to 0. Let me show you what I mean. Well, here we go. To solve quadratic equations, we have the following methods. We can factor, we can complete the square, quadratic, or use technology. This is very important. The roots or solutions of a quadratic, this is the general form of a quadratic formula, or quadratic equation, by the way, are the values of x which satisfy the equation or make it true, which satisfy these equations. Okay, so zero product principle, ZPP, yeah, you know me. You better reply in that manner or there is going to be trouble. Okay, solve for x. So here we have 3x squared plus 5x equals 0. What do they have in common? Looks to me like they have an x in common, so I'm going to factor out an x. That leaves me with 3x plus 5 equals 0. And this is the beauty of the zero product principle. If you remember, that's A times B equals 0. So A equals 0 or B equals 0. Either one, if this is equal to 0 or this is equal to 0, I have a true statement. So I can say x is equal to 0 or 3x plus 5 equals 0. Solving, I have x equals 0. Here, 3x equals negative 5 or x equals negative 5/3. These are my two solutions. This cowboy right here and this cowboy right here. Yes? Note, you can't, if this was x times 3x plus 5 equals 10, you can't set x equal to 10 and 3x plus 5 equal to 10. It doesn't work. It's the zero product principle. Understand what you're doing here. You're having something times something equals 10. These would have to be factors of 10. Like this would have to be equal to 2 or equal to 5 or 1 and 10. Or 1.5 and whatever times 1.5 equals 10. So you can't use that principle here. That is a common error. For part B, we are going to subtract 5x and subtract 6, and we are going to factor. Factors of negative 6 that give me negative 5 are going to be x minus 6 and x plus 1. Again, we're going to use ZPP, yeah, you know me. Either one of these are 0. I set them both equal to 0. And I solve x equals 6, x equals negative 1. Booyah. Moving on. I'm moving kind of quick because really, this should be review for you. Okay. Here, I'm going to set it equal to 0 by subtracting 4x from both sides. You should recognize this as 2x minus 1 times 2x minus 1, a perfect square trinomial, or more quickly, 2x minus 1 squared equals 0. So that means the only solution is when 2x minus 1 equals 0 or x equals 1/2. For this one, I subtract 11x and I subtract 10, okay? And I can factor those pretty simply. I don't care how you factor it. You should know how to factor at this stage. This is going to be, let's see, 6x squared, so I could have a 2x and a 3x. You could split the middle term here. This is going to turn out to be minus 5 plus 2, setting them both equal to 0. X equals 5/2. 3x plus 2 equals 0. X equals negative 2/3. Okay. If you need to know about splitting the middle term, you can Google that, or you can ask, I almost said form, middle term, or you can ask me, and I can show you real quick. Okay. Here we got a little bit of a different situation. What we don't like of this is, first of all, we need to set it equal to 0, and second of all, we have an x in the denominator, and it doesn't appear to be a quadratic just yet, but it really is. Let me show you what I'm talking about. So I'm going to add 7 to both sides. That equals 0. Then I'm going to multiply the whole darn thing by x, and that is to clear this denominator. Distributive property gives me 3x squared plus 2 plus 7x equals 0. I'll go ahead and split the middle term on this one. 3x squared plus 7x plus 2 equals 0, just to make you more comfortable in descending order of exponents. So to split the middle term, I take the coefficient of the squared term times the constant, and then I look for factors of the constant that give me positive 7 to make the middle term. So that would clearly be 6 times 1 equals 6, factors of 6, and 6 plus 1 equal, oops, that's not a 1, 6 plus 1 equals 7, which is the middle term. All right, so then I can rewrite the middle term as such. 6x plus 1x, 6 and 1, 6x and 1x. I'm not writing the 1 because we have on our big boy squirt right now. And then I look at this pair of terms and this pair of terms, and I factor them accordingly. What do these two terms have in common? They have an x and a 3, so I'm going to factor out a 3x, and I get x plus 2. And then I also get an x plus 2 here. Now, it might be that you have to factor something out of here in another type of equation or quadratic, but in this case, we got kind of lucky. Now, I have two distinct terms that have x plus 2 in common, so I factor that out of each of them, and what do I have left? I have a 3x, and the coefficient of this entire term is 1. And from here, you should be easily able to see that x equals negative 2 or x equals negative 1/3. Boo-yah! All right. What else have we got? We can complete the square. This is a skill that you should have already. It's very effective. If I have something like this, x plus 2 squared equals 7, I can take the square root of both sides. The right side must be plus or minus, because if I square a negative on this side, I will get a positive. So that turns into x plus 2 equals plus or minus root 7. So our solutions are negative 2 plus or minus root 7. And no, the 7 is not a perfect square. That is the exact answer. Let's leave it like this. Here, we would take the square root of both sides, and that becomes plus or minus square root of negative 5. We are in the real number system. We cannot handle the square root of negative 5. So for this one, there would be no solutions. Giddy up. All right. Next, what about this? Now here, is completing the square. We can't factor it. We could use the quadratic formula if we wanted to, but we do need the skill of completing the square. How do we do that? Well, I'm going to write x squared plus 4x, and I am going to leave a blank here because I'm going to add something here. So here's plus 1 equals 0, and I'm going to put something here to form a perfect trinomial square with x squared and 4x. And really what's happening is I am factoring backwards. I'm trying to find out what term here I can add or subtract to make a perfect trinomial square. So all I have to do is take half of the middle term, I'm sorry, not the middle term, half of the coefficient of the middle term, which is a 4, and then I square that, and that is equal to 4. It's just a coincidence that this coefficient and my result is 4 here. It's not always going to be the case. So what I'm going to do is add 4 here. So now all of a sudden I do not have the same equation, so I have to compensate by also subtracting 4. Or I could have added 4 to the right side of the equation. But I decided to do it this way. So why in the world did I do this? Well, I've just made a perfect trinomial square out of this trinomial right here. This becomes minus 3 equals 0. I add 3 to both sides. And now I can take the square root of both sides and get x plus 2 equals plus or minus root 3. It's not a perfect square. I'm going to leave it like that. And my solution set is as follows. Okay. And so that's going to do it. We'll get to part number 2 here in just a second. Finish up with some more of the great ABBA. And we'll see you next time because I am out.